Okay, let's look at question number 7. So if we read it, we have an object that's hanging from a spring. So it says if the spring is pulled 3 feet downward and makes one complete oscillation every 4 seconds, what is an equation of the motion of this object? At what 2 times within 1 cycle is the spring 2 feet below the equilibrium position? Okay, so it tells me that the spring is pulled 3 feet downward, okay? So 3 feet downward, we can start by looking at this graph. So if I'm starting 3 and pulling it downward, my graph is going to go to -3 here then. So it says, what is the equation of the motion of this object? At what 2 times within 1 cycle is the spring 2 feet below the equilibrium position? So overall, we're looking for an answer of 2 different times. So again, my midline, okay, so if it's pulled up here, it's at 3 feet, pulled down, it's a -3. So my midline is at 0. So my amplitude is just 3. Remember, it's absolute value. So my cycle is every 4 seconds. So my period is 4 seconds. So if I want to break this up to be intervals, you say 4 divided by 4, which is 1, so it goes by 1 second. We need to find what b is. So 2 pi divided by b equals 4. Solving this for b, we get b equals pi over 2, which is what we have here. I'll leave c blank, and then d we know is our vertical shift, which is 0. Okay, so again, there's numerous different equations you can have here. It doesn't specifically ask for sine or cosine. So I leave c blank so that it depends what equation you use for your phase shift. So for example, I can say y equals -3 cosine of pi over 2 times x minus 0, because if it's negative cosine, remember now positive cosine goes maximum, intercept, minimum. So we're going to go minimum, intercept, maximum. Okay, so no phase shift. If we use positive sign, we say y equals 3 sine of pi over 2 times x minus 1, right? Because it goes intercept, maximum, intercept, minimum. So really the only thing that changes here is your phase shift. So positive cosine is y equals 3 cosine of pi over 2 times x minus 2, because now we're going maximum, intercept, minimum. Or you could say y equals -3 sine of pi over 2 times x minus 3, right? Because we go intercept, minimum now. So any of those equations work. Now we need to find when the spring is 2 feet below the equilibrium position. So that's when we use this -2. If it's 2 feet below, we're going to pick any of these equations and plug -2 in for y. I personally just picked the first one. It does not matter what you use. Also, notice this one has 0, so that's easier for you. So -2 equals -3 cosine of pi over 2 times x minus 0 plus 0. Your zeros cancel. So I'm left with cosine, after I divide both sides by -3, of pi over 2x equals -2 over 3. So I changed this to be degrees. So pi over 2 is the same as 90 degrees. So now I say cosine of 90x equals -2 pi over 3. So I need to get rid of this cosine. So take the inverse of both sides. That cancels cosine out, so I have 90x equals cosine inverse of -2/3. Okay, we're entering this into our calculator. Is 131.8 approximately. Okay, so we say 90x equals 131.8. But remember, there's 2 options for that, right? So we have to say 360 minus that, which gives me 228.2. So now I have my 2 times. So I solve both of these by dividing by 90. So you get x equals 1.46 seconds and x equals 2.54 seconds.